The first portion was graphing and becoming familiar with our parent graph of our exponential function, and now we're going to be solving the exponential equations. And so we want to write each side with a common base if possible. And what that simply means is if I have a base 3 to the x, can I rewrite 9 using a base 3? So what is 9? 3 to the what power? Good, 3 to the second power. When your bases match, then we can set exponents equal to one another. So we would just say x is equal to 2, and we're done. We've solved that equation. Okay, let's look at the same thing over here. I look at these two, and I see this one has a 5, which is a smaller base. It's really 5 to the first power. Okay, my question is, can I rewrite 125 with the base of 5? So 5 to the what power? 5 times 5 is 25, times 5 more is 125, so that's 5 to the third power is equivalent to 125. So yes, I can rewrite 125 as 5 to the third power, and I cannot ignore this x, so I need to leave that x there because it was already there. Once my bases match, that means I can set exponents equal to each other. So I could say 3x is equal to 1, and then we're solving for x. So if we want to get x by itself, divide both sides by 3, and we say x is equal to 1/3. So we're going to continue with this method of trying to make our bases match and see how far it gets us. So we have a look at these two. My left hand side has a base of 2, and this is an 8. So I'm going to ask myself, can I rewrite 8 to have a base of a 2? So I'll leave this side alone. And I want to know 2 times 2 is 4 times 2 more is 8. So this is 2 to the third power. And that's nice when the bases match. I just set the exponents equal to each other, so it's 3 minus 2x is equal to 3. And now we're just basic algebra solving for x. So to get x by itself, I'm going to subtract 3 from both sides. 3 minus 3 is 0. Divide both sides by negative 2. X is equal to 0. So we solve and find our solution. Okay, but what about D? 27 and a 9. If I start with a 9, because they already have a base 9, and I did 9 times 9, it's 81. It's definitely not 27, so I can't do that. Is there something I can rewrite 9 with? Yes, 9 is 3 squared. But I cannot forget this x plus 1 that was already up there. So I can rewrite 9 with a base of 3. My next question is, what about 27? 3 times 3 is 9 times 3 is 27. So yes, 27 is 3 to the third power, and I already have a 3x up there. So you can never lose what you already have up there. We're just rewriting the 27 and the 9 using a base 3. Now that our bases match, we set exponents equal to each other. So we have 3 times 3x is equal to 2 times x plus 1. And now we're doing some basic algebra and solving equations. So we're going to distribute in full. Distribute these out and simplify. So 3 times 3 is 9x. 2x plus 2. Now we want to get all of our x terms on one side. So if I move this 2x over here, I would get 7x is equal to 2. Solve for x, so I divide both sides by 7, and x is equal to 2/7. And that's going to be our answer. Alright, E, first of all, I'm like, it's looking complex to me, and I'm not liking that this has a negative exponent. So I want to rewrite this problem using a positive exponent. Remember I told you if it's a negative exponent in the numerator, then I can bring it to the denominator and it would become a positive exponent, and I just have 1 as a placeholder. Well, I can now see that I can rewrite this using an exponent. So I could say 1 and 27 is 3 to the third power, because 3 times 3 is 9 times 3 is 27. And I can leave this side alone. And now, can you look to tell me what x is equal to in our particular problem? What's x equal to? You see that everything else matches. The 1 equals the 1. It's to the third power. It's to the third power. So it's saying what to the third power. So we just simply pull that down and say 3 is equal to x. Alright, and now f. We're going to be doing some manipulating. First of all, I have e to some power. And over here, the e is on the bottom. First of all, I want to move the e to the fourth power into the numerator. So I'm going to rewrite this and leave it alone. Over here, I'm going to move the e to the fourth up, but whenever I move it from the bottom to the top, I now have a negative sign. So it becomes e to the negative 4. And there is an x plus 1 that was already there. Okay, we kind of like did the reverse of this. We took it from the top, put them on the bottom. It went from a negative to a positive. From here, we took it from the bottom, moved it to the top. So if it was positive, it changed to negative. Anytime you cross above or below the bar, you'll have that sign change. So now we have this statement. The bases, although they're not numbers, they're still the same. So when the bases are the same, we can set exponents equal. So you get x minus 1 is equal to negative 4x plus 1. Good. Now we're just going to simplify this. Distribute over here, negative 4x minus 4. We want to get all of our x terms on the left if we can, or on the same side, however you prefer to do it. 5x minus 1 is equal to negative 4. We add 1 to both sides. 5x is equal to negative 3. And then to solve this out, we divide both sides by 5. And our solution is x equals negative 3/5. So it can be very easy to very complex, but in this particular solving equations session, we're going to be trying to rewrite with a common base.